Morning. My name is Chris Overholt, and I'm a fire protection engineer in the Fire Research Division at NIST. I work pretty much half-time in the firefighting technology group and half-time in the fire modeling team. And I want to talk, there's some overlap of my talk with Kevin's because verification and validation is such an important underlying aspect of our fire model. I'm going to show some things quickly to show the context of them in our day-to-day work. So in outline, I want to talk about the verification process and the validation process in more detail and a little bit of the nuts and bolts and everything that we do. I want to show you that it's essentially transparent. It's all available online, and I want to show you basically some things that we do at NIST on our machines using the code repository and how they end up in items 3 and 4, which are the user resources. So basically some of the things Kevin talked about, where you can find them in the guides and what we do in order to make FDS essentially a better product for you, for the end user. And then I'll talk about how users can contribute in some more detail. So the first thing is, Kevin mentioned a little bit about verification, and that's checking that the math is right. So why would we automate this process? So I want to show you some of the growth of the verification cases over the years. So verification cases we have, if you think of FDS, most of you know that FDS is a collection of submodels, right? So it's a general flow solver with lots and lots of details of submodels. So there's a submodel for conduction, submodel for pyrolysis that Kevin talked about. A new submodel in FDS-6 is HVAC. There are turbulent submodels, radiation, combustion. These are all separate pieces of code within a larger framework that we like to think of. We incrementally develop these things. So as Kevin showed, there's some gaps we can see that connect us to the real world validation. And I want to show you some more detail about what that is and why we do this. So if you think about FDS is about a little more than 100,000 lines of code with all of these types of submodels. Really that corresponds to what we call the code repository. So on this code repository, we have things like the actual source code of FDS, we have the manuals, we have various utilities for us, we have validation, which includes all of the experimental data for some of the things Kevin showed, and we have verification, which is what I'm talking about now. So here you can literally see in folders we have HVAC, fires, evacuation. These are all simple cases that not only serve as examples for how to use FDS, but these also allow us to check the math to make sure we're doing things right. And as we make changes day to day up to the next major release or minor release, we want to make sure that this is all working correctly. And this quickly becomes a problem of scale. So if you look at the number of verification cases over time, on the x-axis, this is the revision number. On the left, revision 2000 is about the year 2008 up to present. Right now, the FDS revision number is about 20,400 today. And if you look, I've put vertical lines in where the point releases of FDS are. So when FDS-6 was released back in November, that's to the right, and on the left you can see how we've grown the number of verification cases. So this is in general a good thing, and so this is us doing more rigorous checking on those submodels. And so we're up to about 600 cases. We run about 400 every single night to do major rewrites of the code that are going to slow the code down by huge amounts. We like to spend a proportional amount of time on, for example, since we are a gas phase code, we're not going to spend half of the time on the solid phase and so forth. So this lets us track some of that history as we make changes. So that's kind of the verification, and you can see that from that chart I showed, we're up to 600. We hope to keep growing that. Something Kevin mentioned was contributing experimental data, but just as helpful is to contribute verification data. If you're a student working in some of those areas, it's just as helpful to get a verification case. Often these verification cases come from bugs. So if someone reports a bug and says the HVAC solver is not working or the turbulence is not working near the wall, we'll fix that and add a verification case. And if the bug reporter is really helpful, they might help us with that and say, I made a simple verification case. Then we put that in our nightly testing suite to ensure that things like that don't happen ever again. Now I want to talk about the validation process. Kevin talked a lot about that, and so some of these slides I have will lead up to the user-facing side of this. As Kevin mentioned, we first put together with the Nuclear Regulatory Commission a a verification and validation project, which led up to NUREG 1824. The original NUREG 1824 included data from 26 tests. The refresh of this Supplement 1 to NUREG 1824, which is close to the period for public comment right now, so it should be out within a few months, now includes 860 individual experiments. So here, I'm not showing a nice plot like I did before because there was the first version and the supplement, but we went from 26 experiments to 860. So 5 years from now, 10 years from now, where will we be? And obviously, we can't do that by hand. So here's kind of some of the behind the scenes of how we automate that. And in order to produce the tables and plots that Kevin showed, we were using data from 44 experimental data sets. And this is sort of an ongoing process. We'll sort of never be done because we're approximating reality. And because we're adding new functionality, we always want to add more and more validation data to represent the real world. We have 5,000 point-to-point comparisons. And again, the supplement was updated to use the latest version of FDS and CFAST. On the correlation side of it, I'll briefly mention that there is a corresponding validation guide for the correlations. This has been published as NIST Special Publication 1169. And essentially what we've done is to codify in source code the correlations similarly to how we do CFAST and FDS. So now, again, for the AHJs or for the model users doing performance-based design, we have kind of across the board correlations, CFAST and FDS, and the corresponding validation guides for those. And we're doing this so that we can grow this set of correlations. So if a new correlation comes out, we can literally test it against the existing correlations to see, is it more accurate, less accurate? So NUREG 1824 includes the results, like Kevin showed, of correlation zone models and CFD models. Kevin mentioned some of these output quantities, and I'm going to show where that comes to. So in the FDS validation guide, we have a number of different documents. We have a validation guide, verification guide, and so on. In the validation guide, you'll find lots of scatter plots like this. This is really the meat of the validation process to date. So every night when Firebot runs, it's basically collecting the experimental data we have using existing runs that we're kind of doing on an ongoing process and showing you this is where we are today. So if a version of the model is released, you have the corresponding scatter plot. That's it. That's related to that model. If you look at an updated version, you'll see these statistics change for better or worse, depending if we add new data or if we change model functionality and reran those cases. Kevin showed this chart, and it shows the correlations, CFAST and FDS, and these quantity of interest. This is in NUREG 1824, but again, these numbers are coming from the automated process that happens every night. So whereas this is going to get published and sort of locked into that version of FDS that's mentioned in this NUREG document, in the FDS guide and the CFAST guide and the correlation guide, these numbers will continue to evolve. So the best idea is for the model version that you're using, go to the validation guide and you'll see a table at the end that looks like this, and I'll show that later on. Kevin mentioned some of these quantities, but essentially I just want to say the automated aspect of it is that validation bot is running at least one data set nightly. We usually ramp this up as we get closer to a release. CFAST bot is doing the same thing and running against CFAST. So you might have noticed CFAST is a bit more bug-free these days since this whole process has been applied. And that actually runs the entire suite every time a change is made to CFAST. And correlation bot runs these correlations guide on demand as we add new data or correlations. Again, looking back, just like in verification, we could look at the performance. Validation, we can look back at the accuracy. So we can look at things like the hot gas layer temperature, sealing jet temperature. So again, I'm showing the revision number on the x-axis and the bias. So above 1 means it overpredicts, below 1 means it underpredicts. And this kind of lets us look to see what change did we make that kind of shifts these accuracy. In other words, if you're a graduate student proposing a new submodel or a change, what will that do to the accuracy versus the cost, which I showed earlier, the verification. So now that you've seen kind of the behind-the-scenes work that we do, which, by the way, I say behind the scenes, is all available on our source code repository. Nothing that we do isn't on there. I want to bring you to what resources we have available for users. So I mentioned the various documents we have. A lot of people look at the user guide, but not go much further. We have lots of documentation. The technical reference guide has all the governing equations for the different submodels. So if you're wondering how we do smoke detection, how we do turbulence, how we do combustion, it's all in there. We have the verification guide, which has those 600 cases documented and the expected answer. It has the validation guide, which has the 44 and growing data sets. And then SmokeView user guide, technical guide, and verification guide. So these are all packaged with the FDS bundle, and the updated nightly versions of these are online. So what's really neat is someone will report a bug to us, we'll make the change and fix it. Next day, we'll point them to the nightly documents and say, does that look right? Is that fixed? That's what we're trying to do, is more rapidly iterate that to get things right away instead of having them kind of haunt us later on. In the back of the FDS verification guide, there is a table called, in Appendix A, called Summary of Verification Results. This is the result of those hundreds of verification cases, literally for that version. So as Firebot works every night, we'll choose one of those to release as a bundle. You can go to the back and you can see for all of these verification cases, here's the expected number, what FDS predicted, if it's within tolerance. If it's not within tolerance, Firebot is angry. Firebot will let us know and we'll fix it to make sure. But you can, this is a way for us to be transparent about our V&V process all the way to the end user. So you can literally point to the back and say, is everything in tolerance? Is everything working as it should? A lot of this has to do with software certification, making sure that the version of the software that you're using is the same that we're using. You can use that in the same way. In the validation guide in the back, Kevin pointed this out. This is in near the end of the validation guide. This is kind of a summary of all of those scatter plots. So for any given scatter plot, say you're looking at hot gas layer temperature, forced ventilation, you know that the scatter plot tells you it overpredicts by 27%, and I can see that on the very right with the bias, and I can look at the model uncertainty, sigma m. So for all of those scatter plots, this is a really dense table to say how well are we doing compared to reality, and Kevin talked about that, but that's where that is in the validation guide for every version of FDS. Moving forward, there's some normality test that shows you, and this goes back to what Kevin said, are we using one data set? Is it kind of just one bar, or have we filled out this bell curve to really, where do we need more data? Where do we need to work more in validation? This is also in the back of the validation guide. Just past that in the validation guide literally tells you the last time these cases were run. So again, if we're running these cases continuously, this is telling you and us that what the turnover time is for our validation cases, because some of them do take days or weeks to run. We're trying to make sure that we get all these updated for the next point release of FDS. We have lots of wiki pages in addition to the guides. We have one for how to access the repository. So this allows anyone in here, this is publicly accessible, you can anonymously check out all of the source code that we use to not only develop FDS, but to do all of the things I'm showing you, the verification, the validation. And this is often how students, including myself, Craig, who's going to talk tomorrow, Julio, have all worked as students in the repository, and then as they progress with their research, we don't get a dump of data in the end that we sometimes can't use. It's more integrated into our process, and that's why Kevin says contact us early on because we can get you in this system. There's also a build status page for Firebot, so this basically shows a green light, yellow light, red light, depending on how angry or happy Firebot was that night. So users can literally see, if we have collaborators that are working outside of NIST, they can go to this page and see what's the state, what's the health state of FDS, how is it doing as we make changes. There's a lot of links on our page, and I'll point some of those out. There's the nightly FDS manuals on the top. This has the nightly guides that Firebot builds, and there's a link to Firebot right after that to see the previous slide that I showed. There's a YouTube channel. You can follow us on Twitter. We have a collection of publicly available reports. So for most of the validation guides, the ones that have publicly accessible reports, you can pull up the report directly. So you can pull up the FDS validation guide, the case in FDS, and the test report. If you're an AHJ or if you're doing performance-based design, to literally look at the same thing we're looking at and the input file. And the roadmaps at the end kind of show what directions we're heading in and where we think areas of research are, such as pyrolysis. So the final thing I want to talk about for a couple of minutes is how can you contribute. Kevin mentioned before that you can contribute validation data, but there are many other ways to contribute that are just as necessary. there's actually a wiki page for that. How can I contribute to FDS? So here we talk about you can contribute through user support, through documentation, through verification, through validation cases. There is a page that we've made just for this purpose that says, here's an example setup of a verification case. So again, great for students, or if you're just working in an area that is not clearly defined in our documentation, you can work with us and we'll certainly help. But this goes through the process of setting up a verification case. So setting up the equations, setting up the FDS input file, and actually setting up the statistics so we can make it live in FDS. Because the worst thing for us is something that kind of comes up and then dies but doesn't get put into the whole process. So the last thing I'll say is that the FDS project embraces open source development. Everything we do is available on our repository. Continuous integration now with FDS6 moving forward. Software quality testing, I showed you some examples of that. Performance metrics, which are great for us to look version to version how we're doing. Parallel and high performance computing, this is very big right now with both MPI, which is between machines, and OpenMP, which is utilizing cores on a single machine. This is, we're very much trying to be on the cutting edge. And on the next slide, I'll tell how you can help with those areas. And cross-platform compatibility, we try to run on Windows, Mac, and Linux equally. So we test on all those platforms. And finally, contributions from the users and community, which is really driving all of these applications. So finally, I'll say the ways you can contribute, in addition to what Kevin said, feature testing. This is huge. So right now, we actually posted a call for people to help us test the MPI, or multi-mesh version of FDS for Windows. And we didn't hear back anything. So we've tested it in this, but we really want to make sure, what is it doing in the real world? Does it work? So this is huge for us because we essentially spent the entire summer developing this, but without testing, we don't know what to do with it. So we need feedback on that. And that's as simple as downloading the binary, running it yourself for a few minutes, getting back to us. It worked or it didn't work. Documentation is big. If there's some area that's not clear, tell us, and we can work with you to make it more clear. The discussion group is very active. Verification cases, like I said, any student or someone working in the area can help us contribute and basically make our code stronger via the community. Validation data sets, Kevin talked a lot about that. Bug reporting, if you find a bug, report it. We find a lot that when we come to conferences in person, someone will tell us, there's this bug that's been there for a couple of years, and why didn't you tell us? You throw it on the discussion. We use the turnaround time is very quick. We have good customer service, I promise. So just report it up on the discussion group or on the issue tracker. And finally, improving the submodels. And this really goes to like a graduate student working anywhere in the world of fire dynamics, or whether it's correlation zone model or FDS. You can really, I think everyone wins when they contact us early because we get the benefit, the users get the benefit, and they get sort of a better, more practical education as they go through that process. So thanks a lot for your attention, and we hope to have you participating. Thank you.